detected him, it seems. Okay. Okay, pay attention. I think I will discuss history again, but this will be interesting now. We'll see how interesting it is. Yeah. So what happened in the history of microbiology? Tell me, students. You know?
Discovery of
Yeah. See, first we are thinking about discovery of microorganisms. The actual groundbreaking contribution in the field of microbiology happened with the invention of microscope, right? Microscope. So there itself the microscope has issues. So there is one physicist. He made a microscope, and his name is Robert Hooke. Okay, Robert Hooke. But the Robert Hooke's microscope is very, very costly. Okay. By the way, before the Robert Hooke, how Robert Hooke came to this idea means, before him there is Galileo. There are many scientists who are working on telescopes. So they are working with magnification of celestial bodies or far away objects, right? Telescopes. So what Robert did, he modified the lenses and he started observing the nearby objects. Okay, the microscopic objects. So yeah, that's a very groundbreaking contribution by Robert Hooke. But Robert Hooke's microscope is very costly. In today's currency, it will be around 2 lakhs, 2 to 3 lakhs. Okay, so not everyone is an affordable of microscope, and microscope became a status of brand, okay, a status symbol. Only the rich can have a microscope, not others. By the way, if rich have microscope, they won't do anything. It's just a funny thing, right? So the first and foremost thing is we need to reduce the cost of microscope. Then in the history, very interestingly, there is a person by profession, the person's father is a very good glass maker. Okay, he is a glass maker. So he is making glasses, and his son, what his son did is, I will give son name here, mysterious. What son did is, he want to polish glass into very smooth. He want to make a very smooth, polished marble. You want to make a glass so smooth that it will be very transparent and it will be a small marble. Is there any use of polishing a glass? So for past 7 to 8 years he started polishing a glass, okay, without any creases. Keep in mind this is 700 years ago. So very tough, okay. You can imagine you have only rocks and small tools and you want to polish a glass. That is the challenging thing. So what he did, he polished a glass so well, it's a small ball, and what he did, he kept this glass of ball in a copper plate, copper plate, he kept a ball. And to this plate, he made a small modification, he kept a screw and he kept a specimen under this glass. So the overall size of his apparatus is this much only. Okay. So with this copper plate small glass, he kept a drop of water and he started observing directly through sunlight. Okay, to this small hole where there is a small glass. Okay, this is the first first microscope that has a groundbreaking contributions in microbiology. Okay, this microscope cost around 200 rupees. That's it. With 200 rupees, you will get a best microscope. Okay. Yeah, and do you know who is this scientist? He is our Anton van Leeuwenhoek. That is how the microscope came. Okay, now microscope came into the hands of normal persons. So the now normal persons started using microscopes. Hello. They will automatically understand that. That's why I kept class. Anyway, yeah. So now what our Leeuwenhoek did is, he started fascinated by the world. He started whatever sample he has. First he took a leaf, he observed the leaf, he drawn the pictures of leaf, microscopic picture of leaf. Then he took a drainage water and he observed the drainage water. In the drainage water, he saw something very interesting. There are small animals. Okay, the knowledge of humans is animals only. So he thought there are some small animals like things. Okay, Then what he did, another one is very interesting. He took the semen sample, his own ejaculation, and he observed under the microscope. He kept the semen sample and he observed under the microscope. And he was terrified. That's it. He thought that semen don't have anything, it's pure sample. Okay? He was terrified because there are multiple microbes wandering in the semen sample. And he don't know what are those. He was afraid whether, is it normal or is it everyone has these things or only for him? Okay? And you know what he said to that semen sample, that sperms? He said them as an animal clues. Okay? See, there is an interesting history behind sperm's discovery. Okay? That is Anton van Leeuwenhoek, and he said them as animal clues. Okay? Now the next generation, so-called new branch came. Maybe these animals responsible, maybe these are tiny babies wandering in the semen. Maybe that is how the life originating. So they started observing other mammals. They started observing other animal kingdom, and everything has these forms. So yeah, microbes might contribute to something groundbreaking, something even responsible for the origin of life. Okay. So yeah, that is one part of history. So they came to know that microorganisms are there. But no one has thought that microorganisms will cause infection. Keep in mind. No one knows at this time what is the role of microbes. No one knows that microbes will cause an infection, first of all. Okay. Then the next generation, there is a huge debate in the biologists. There is a huge debate in biologists. The debate is how life originated, how life came to earth. According to the book of Genesis, the Bible, they says life came from God's will. Okay, let there be light, let there be land, let there be animals. That's it. It's not as simple as that actually, right? So yeah, there are two debates among biologists. One is biogenesis theory, and another one is abiogenesis theory. This plays a very important role. What is this biogenesis and abiogenesis? There is a scientist called John Needham. He did a very interesting experiment. He said he took a meat ball, okay, a chicken piece, okay, and he kept on a table. After 1 week, what happened? This chicken meat has many worms. Many small worms came to the chicken meat. So he proposed, yes, abiogenesis, okay, I am discussing about abiogenesis. Life will origin from the egg. That is his idea. Okay, life comes from egg. Because that is what he observed. He took a meat and he kept exposed to the egg, and somehow microbes, somehow the worms came to the meat. So there is some power in the egg, maybe God, maybe ether. Let's say that energy is ether and the God giving life. No one still knows that, from parents we are getting children. They thought that children is a God's gift. Just remember that is a history. Okay? You will participate in sex and you will get somehow mysteriously you will get babies. But they don't know what exactly the reason. Okay? Really interesting things. Then came a second generation scientists who were critically thinking, no. At that time, telling against God is a very crime. Okay, it's a sin. You will be executed to death alive by the public, by the society, because God is omnipotent, ubiquitous everywhere. So scientists have some problems of disproving this God theory, so-called abiogenesis theory. Right? Then what these scientists did? They came with one experiment. That experiment is, they took a flask, okay, they kept broth, that means the meat, okay, they kept meat in a broth, then they sealed the glass. Okay, and they observed. So there is no ether, there is no air in the glass. Will there be microbes? This is the experiment. The scientists trying to disprove abiogenesis. Let me seal the glass. Let me see the class and let me see what happens. And interestingly, worms still came. Why this happened? Any logic? Even though they sealed the flask, but still the worms came. After 1 week, there are worms inside the broth. How is it possible? Anaerobic microbes. There are still some microbes that has been, this meat has been exposed to environment. There are some, okay, so this idea of, so again this experiment proving abiogenesis theory only. Okay, it is still proving abiogenesis theory. Then what they did, okay, let us heat it. Another scientist came and they said, let us heat it, okay, and let us see. After heating, there is no microbes. Obviously, when you heated it, there is no microbes. They kept broth and they heated, there is no microbes. And what the scientists said, they said, we killed the ether. I think we killed the soul of God. Maybe the God which is present in the air has been died. So that's why there is no life. Still, people can't get the idea of what is life. See, okay. So there is one scientist. He was frustrated by these ideas. Okay. His name is Louis Pasteur. What Louis Pasteur did? I need to cross verify whether it is Louis Pasteur or the other one. 1 second. Let me check it. Yeah, that is Louis Pasteur. So what Louis Pasteur did? He came up with a modification to this experiment. What he did is, first he heated a broth, so it became sterilized. Okay. Then he took the same flask. He kept the meat. Okay. He heated it. Then what he did is, after heating the broth, there might be some air that might have some microbes. Even that microbes can cause growth of worms. So what he did is, he bended this glass like this. He bended the glass and he kept water here. He kept water. Okay. So this is a bended flask. Keep in mind. So there is no water first. He kept broth. He heated it. All the air escaped from the tube. Then he kept water and he boiled again. So again sterilization happened and some of the water acted as a natural barrier. Okay. Now there is no growth in the swab. This is called as a swab neck flask experiment. Okay, it looks like a neck of a bird. Swab. Okay, swab nest. Then what he did? There is no growth now. Now he break the beaker. He break the beaker. Again, there is a microbial contamination. There is a microbial contamination. Then he heated it and he sealed it. There is no microbial contamination. So he disproved abiogenesis, stating that the life coming from life, maybe the air is not sterilized. The air has some microbes. That is why the microbes are generating. When you sterilize the air, there is no microbes. When you don't sterilize the air, there are microbes. That means air has some microbiome, some microbes present in the air. He took this air sample. He given this air sample to a sterilized sample, a sterilized thing. Again we got a go. So he said that life origins from life. It's not from air, life origins from life. That is biogenesis theory. Okay, this is really interesting. Now he understood life origins from life. Okay, that is Louis Pasteur. Louis Pasteur has single-handedly proved that the life comes from life only. Okay, when you sterilize, there are no microbes because we are killing the life. Okay, yeah. Then what Louis Pasteur did, the other things, very interesting things. During that time, there is a pox all around the world. There is a plague. A pox plague is happening across the Europe. Everyone getting some mysterious viral infection and they are dying. They are getting skin blisters. Okay? During this time, what our Louis Pasteur did is, he had a friend. He had a friend called Edward Jenner. Okay? With the help of Edward Jenner, what they did is, they started doing statistical analysis of population. Listen, this is really interesting. All population getting infection. Okay, all people getting infection. Even during a pandemic time, during an infectious period, some people not getting infection. Only few people in a family is not getting infection. A son got an infection, but mother didn't get infection. How is it possible? According to biogenesis theory, infection should spread. But why an infected son's mother not getting infection? Okay, that we will see. Okay. So similarly, what they observed is, whomsoever people they are not getting infection, the people they are not getting infection, they started interviewing them. What are you doing? What is your lifestyle? And they came to know that most of them are milkmaids. Their profession is taking milk from cows. Then they asked another question. Acha, so you are a milkmaid. Then they asked, is your cows are fine? Then they said, no, our cow got some infection. They said they are working with infected cows. See, there are two types of milkmaids. A healthy cow milkmaids, they are getting infection. But an infected cow milkmaids not getting infection. A healthy cow getting infection. Milkmaid working with a healthy cow got infection. But a milkmaid that is working with an infected cow, they are not getting infection. There is some connection. Okay? Maybe this cow infectious material somehow protecting the milkmaid. Somehow protecting the milkmaid. This is the observation by Edward Jenner. So Edward Jenner said this his idea to the Louis Pasteur. Sir, this is the phenomenon I observed. What we need to do? Is there anything? Then Louis Pasteur took it to the next extreme. He said, you know what is the Latin name of cow? The Latin name of cow is Vanza. Now you can understand. Okay? So what Louis Pasteur did? There is an infection, so he called his own son. Beta Robert, okay? He took his son, then with pure confidence, he took the cow access, he took the cow wound, and he given wound to his son. He dissolved the wound in a water and he said, drink it. Drink the wound, infected wound material. So the son drink the wound, okay? He took a small kid, he given a cow infected material, okay? Thinking if he exposed to cow material, he should not get infection. He should not get a chicken pox. Okay, chicken pox infection. Now the deadliest experiment. He waited for 1 week after giving cow material. This is the deadliest thing. No, most of the scientists cannot do these things. He kept an actual cowpox to his son. It might kill the son now. Keep in mind. He took an actual chicken pox and he gave a chicken pox to the son. He waited for an extra 2 weeks whether his son will die because of consequences of chicken pox. Interestingly, it is 2 months, 3 months, he is healthy. Then came to know the concept of vaccination. Immediately he said, take all the infected cows, take the material, immunize the population. This virus will go. And as we know, we have tackled even COVID pandemic because of the concept that is given 200 years ago by a pure examination. But still, Louis Pasteur don't know what are microbes. But still they don't know how microbes causing infection. But he understood the spread of infection from surface knowledge. See that how science works? Observational studies. There is evidence and that's how science works. But Edward Jenner did this one. Then our Louis Pasteur did a very interesting thing. He's always associated with milk products actually. So what he did, most of the milks, after 1 or 2 days, milk will be spoiled. Then he said, maybe the milk has some bacteria, I don't know what is it. Let me heat the milk for around 52 degrees centigrade for just 15 to 30 minutes. Okay? Now this milk won't be spoiled. As he said, it's not spoiling. Milk that is preheated with a certain temperature is not spoiling at all. He said maybe when I'm heating that bacteria die, so that's why my milk became fresh. He said even a non-boiled milk is safe. At that time, raw milk is not safe. Okay, and you know what he said? This technique, sometimes it is really interesting. It's a very pride. You observe something and you give your name to the technique. That is a good thing, right? Like if I came up with some idea, then I can say Vamsification. Vamsi is, like that. Yeah, he said that is a pasteurization. The pasteurization concept came from a microbiologist, right? Pasteurization, Louis Pasteurization, okay? Sterilization, a type of sterilization. Yeah. See, Louis Pasteur, then he did really other interesting things. He went to an extent for rabies vaccine. He developed rabies vaccine. Very, very interesting thing. He took an infected dog, okay? He killed the dog. We know that virus might be in the neural system because rabies symptoms will be mental disorders, aggressiveness. So what he did is, he took an infected dog. He wanted to get a sample from the dog and that sample should be given to humans to get immunized. So what he did is, he took the dog, he killed it, he took the dog brain, he kept the brain and spinal cord on his son, he kept a newspaper, he kept a brain and spinal cord, and he dried the brain. Okay? After drying the brain for 1 to 2 months, he made a powder out of that brain. Okay? Then he given this powder to the people, and that became a rabies vaccine. Okay? See, this is how vaccines works. That's why we will say brain heart infusion, brain heart agar. Okay? Brain heart infusion means there is a brain and heart of that specimen. We made a powder and we are giving it. See, interesting things. That's why the father of microbiology as a whole will be Anton van Leeuwenhoek, okay, and he is also father of microscopy, okay, and father of microbiology. But Louis Pasteur is also contributed as a father of medical microbiology. Medical microbiology, the microbes concerned with the humans, right? So Louis Pasteur is called as father of medical microbiology, whereas Anton van Leeuwenhoek is the father of micro and even microscopes. Okay? Yeah. This is some interesting things in the history. Then what happened with the next generation scientists? Louis Pasteur still don't know what exact microbe causing these infections. He's just doing blind studies. For this infection, let me take your sample, let me give as a vaccine candidate, but he don't know what is that exact. He never studied microbes under microscope. Okay. Then came the next generation scientist. That is Mr. Robert Koch. Robert Koch by profession is a bacteriologist. Okay. What Robert Koch did is, Robert Koch, one second, let me see the notes, his contributions. Yeah, by the way, Louis Pasteur also contributed to anthrax vaccine, anthrax, okay? Anthrax, rabies, all these things have been developed by Louis Pasteur. Then I will tell about Robert Koch, one second. What Robert Koch did is, one second. Actually, I was distanced from microbiology subject, so I need to go through the history once. Robert Koch did some of the important things. He worked with a scientist. That scientist made a dye. That dye can visualize microbes under microscope. Okay? That dye is called as, that scientist name I will tell you. Hans Christian Gram. Okay, Hans Christian Gram. He has a friend called Hans Christian Gram. So Hans Christian Gram said, Mr. Robert, I think I made a solution. This can able to colorize microbes. This might be some useful. Do see. So Robert Koch took to Hans Christian Gram's, Gram's tale. He classified. Grams himself has classified microbes into two types. Okay, Grams positive and negative. Okay, but he don't know the significance of this staining. Then he approached Mr. Robert. He said, I came to know bacteria are two types, negative and positive. Can you help me? Is there any medical importance? Then Robert Koch started studying with the help of stainings. He said there are many types of microbes. Since there is a rich history of microbe examinations, there are many types of microbes. They divided them to parasites, bacteria, fungus, and virus is not there at that time. Now, among these three, in a petri dish, if we get a growth, how can we say it is a bacteria? It is bacteria, we can say by Gram staining. But listen, there are many types of bacteria in the environment. Okay, both infectious bacteria and non-infectious bacteria. But you will get growth of everything on a petri dish. How to isolate a medically important bacteria from a group of heterogeneous population? That is the problem of Robert Koch. He is getting growth on a petri dish. He is getting bacterial growth. But how can he be sure that this bacteria is responsible for his infection? How to connect a bacteria to the infection? Got my problem? That is the problem of Robert Koch. How to connect a colony to the infection of the patient, to a particular disease, is the problem of Robert Koch. He need to standardize, he need to come up with some techniques or some ideas to connect a colony to a disease. So he came up with a nice idea. The rules are called as Koch postulates. What is Koch postulates? Koch postulates will connect, the idea of Koch postulates is to connect a microbe, a bacteria, to a disease. So, what he said is very interesting. He said 4 things. For example, my disease is some abscess in the hand, some particular white abscess came on the hand, and he want to say this white rash is particularly to this bacteria. He want to connect it. Okay, so what he did is, first one, the rash must be constantly associated with a particular specimen or colony in a petri dish. Whenever I got a similar rash among 4 patients, when I took their sample, when I am keeping in a petri dish, I should get same creamy colored colony from similar rashes. So there is one connection. If I am getting cream colony, that indicates this cream colored colony is contributing to hand rashes. Okay, that is first thing. A rash, or write down first postulate. The organism should be constantly associated with the lesions of the disease. The organism should be constantly associated with the lesions of the disease. The organism should be constantly associated with the lesions of the disease. That means this organism always should produce same lesions. That's it. Now we understood. The first point is organism should make same lesions. Okay, that is one rule. Then the second rule. Second rule is, when I got a lesion in a patient, when I take a sample from this patient, and when I introduce in a colony, I should get the same colony again, like previous. That means, write down, second point, we should able to isolate disease causing organism in a pure colony. rash must have a characteristic colony. Then second point, when I take the rash and keep in the petri dish again, I should get the same colony. Okay, it should be connected. Then third rule. The third rule is like this. The third rule is, from the patient, I took a sample on a petri dish, right? Now I will take this petri dish material and I lifted this into an animal. I will give isolated colony from an infected patient. That isolated colony I will give it to an animal. Now that animal should get similar rashes that we observed in the patient. That means it says everything is same. In the animal must show rashes similar to humans. So there is a strong connection. There is only one particular bacteria, same colony, same infection. Even in animal it is showing same abscess. So these three are same. These three are same bacteria causing these issues. Fourth and final. Even from this animal when we are taking a sample and when we are keeping on a petri dish, this colony should be same like the human's colony. That indicates everything is same. Even when we are collecting back from an animal, it should be same colonies like human colonies, human infectious colonies. That indicates everything is same. So if anything that is following these four rules can be a strong candidate that this is causing that infection. This is called as Koch postulates. When we are saying this causing this infection, it must follow Koch postulates. That is the idea. Okay. For example, staph aureus causing some skin abscess. See, Robert Koch did very interesting things, right? So he worked with Hans Christian Grounds to standardize bacteria. Then he understood how to connect a bacteria to a bacterial infection. That is why he was coined as a father of bacteriology. Robert Koch is called as father of bacteriology. He is called as father of bacteriology. One of his important contributions is tuberculosis. He studied extensively on tuberculosis, okay, and cholera, Vibrio cholera. So what his study of Vibrio cholera is very interesting. He took a stool sample, he injected the stool, and he is observing stool samples. What colonies we are getting from stool? I'm re-injecting in an animal, whether it's getting diarrhea or not. Then the second, okay, everything is getting diarrhea even after pure colonies. That means this is contributing to that. Let me see the shape of this colony. Oh, this is Vibrio cholera. This has some shapes, Vibrioids. He collected everything. So he started connecting diseases to a specific bacteria. Okay, they have intense. You just imagine there is no internet at the time. There is no rich people, rich knowledge people. But you are making your own data with a, it won't take even 1 year today. These are the observations for his lifetime, and we are studying a matter of minutes in this classroom. That is the importance of understanding history. He took all 40 years to develop his postulates. 40 years he is constantly studying various diseases. He want to prove it. Yeah, I'm correct. Okay. Yeah, this is the idea of Koch postulates. Okay, now you understood the role of Robert Koch in the history. Now you know what is Louis Pasteur's, Edward Jenner's, Hinston Grams, Plato and Leeuwenhoek. Right? Even Robert Hooke can be contributed, but Robert Hooke is like Steve Jobs. He's like Apple. You don't mind innocence. Not over age. Anyway, next. This candidate, I really admire this candidate in the history. This candidate is Joseph Lister. Very, very, very interesting candidate, and he has a good friend. Every scientist has a friend. See, his good friend is the great lady, the great Florence Nightingale. Do you know who is Florence Nightingale? Have you heard about Nightingale? You have heard about Nightingale, to my knowledge. Nightingale. Okay, Nightingale. She is the mother of nursing. She single-handedly brought. She's a nursing actually. She is a nurse. Okay, she is a nurse. So let me tell you the story of nurse. So let us keep writing the lesson. Let us come back to the problem with the doctors. Doctors themselves used to think that they are gods in that old time. No, they are giving life to patients. They are bringing from death. What happened now? Doctors have an attitude that they don't wash their hands. Whatever patient coming, they will directly come. They will take some bloods, everything. They will start cutting. If he is alive, okay, acha, God. If he died, okay, you don't have mercy of God. That's why you died. Okay, only two statements. If the patient died, I am God. Okay. If patient died, you did sin. That's why God killed you. Anyway. Yeah, actually what happened with doctors is whenever they are doing, this is a patient undergone surgery, after surgery they are developing some abscess at the cut site, wherever doctor cut it, then they are getting some infection and they are dying due to this sepsis. This is called as post-surgical sepsis. The rate of death is very high because of sepsis rather than the actual problem to the patient. When you are not even surgically treating them, they will be alive. But when you are doing surgery, they are dying because of surgical issues. Okay? Then what our Joseph Lister said is, maybe patients are already having some infections and we are using same blades for all patients. These blades carrying some infectious material and this is causing cross-contamination and patients are dying. And he said to the doctors, no, Joseph Lister is a normal guy, like me. He went to hospitals and he said, doctors, why can't you clean your hands? Why can't you clean your instruments before doing surgical? They got irritation. Who are you to tell us? You just get lost out of this hospital. Get out. But our Florence Nightingale, she understood. Okay, doctors are good, but let me treat the patients with love, empathy, and with more hygiene conditions. She started practicing hygiene in a hospital environment, and she was regarded as a goddess. They used to think her a descendant of Mary. Okay, Mary, what? Jesus' mother. They used to think Nightingale is Jesus' mother because she's saving lives. She's polite. She's hygiene environment. Patient, at the end of the day, a depressed patient will love. At that time, when you are, you are keeping disgusting face on them, that is very painful to their hearts. So yeah, our Joseph Lister said to the Nightingale, Miss Nightingale, please clean your equipment before the doctors entering into the surgical room. Clean your equipment with my boric acid. He given acid also. Please clean your instruments with this. And please tell doctors to clean that, okay, please. So Nightingale said to the doctors, and miraculously, the post-operative deaths has been fall from 70% post-operative deaths to 0.3% once they cleaning their hands. Cleaning their hands has a huge role. And that again, giving credits infectious microbes with infections. So whomsoever patients got abscess, they given samples to Robert Koch. He said this is the bacteria killing them, and boric acid is very excellent candidate to kill the bacteria. So that is the contributions of Joseph Lister. Okay. So Joseph Lister is credited as a father of antiseptic surgery. Even though he is not a surgeon by profession, he is regarded as a father of antiseptic surgery. See, yeah, good deeds won't be lost. When you are doing good, you will be regarded. Right now, Joseph Lister is called as father of antiseptic surgery. Father of antiseptic surgery. And he is also a father of disinfectants. He advocated the significance of disinfectants. Okay, disinfectants. Boric acid is a disinfectant. Yeah. This is the role of Joseph Lister. Then, shall I proceed or is this enough for today? Is there any other class after this? Okay, thank you very much. This is addition. See, it's nice, right? When you learn with curiosity, this will be interesting. If you buy hard in front test,